In this video, we're going to be finding the derivatives using the product rule. Alright, so what's the objective? The objective is to determine when do you apply the rule, the product rule. Do you apply it or do you not apply it to the function? Do you apply it to part of it? Do you apply it to the whole thing? Alright, and then finally, you find the derivative using the product rule. So here we go. There's two things that can happen in a problem. Let's pretend that I have a function here. I have x cubed times x to the fifth. And what we can do is we can always do the derivative and then simplify, or simplify and then take the derivative. Well, what happens is mathematicians found out that there was a mistake that if you were to do the derivative, so let's take the derivative of this guy. So let's take the derivative of this. This is going to be 3x squared. And the derivative of this one using the power rule is going to be 5x to the fourth. So if I multiply those out, it's going to give me 15x to the sixth. That is what they get if I take the derivative and then I simplify. So what happens if I do the opposite? Let's go ahead and simplify. So I'm going to take x cubed times x to the fifth, and I'm going to put them together. That's going to give me x to the eighth. And I take the derivative of x to the eighth, and it's going to give me 8x to the seventh. This guy and this guy are not the same. So one of them is wrong. Well, I'm pretty sure that we applied the rules for algebra. X to the third times x to the fifth is x to the eighth. X to the third times x to the fifth is x to the eighth. That's like we've been doing that for many years. And the derivative of x to the eighth is 8x to the seventh. So that's correct. Now up here we found out that by taking the derivative of this and taking the derivative of this, multiplying them to simplify it did not work out. So that's where the product rule comes in. What happens when I'm multiplying two x's and I want to find the derivative of that? Okay, so there was an error in the first scenario. So what is the product rule? Okay, the product rule is the derivative of f of x, that's going to be some function of x, and another function of x, and I'm multiplying them. So that means that I'm going to take the derivative of the first function, and I'm going to multiply it times my second function, plus the derivative of my second function times the derivative of my first function. Now, you're saying, sir, that looks complicated. When are you talking about a function? Let's pretend I gave you x squared times ln of x. So right here, this guy would be my first function, f of x, and this one here would be my second function. That would be my g of x. Now, students had a lot of difficulty many years ago. I was teaching calculus in the 90s, and ABBA was a very popular band, so we decided to call this the ABBA rule. All right? It was Dancing Queen. All right? So what's the derivative of a times b? Well, the derivative of a times b is going to be a prime times b plus b prime times a. Now, do you see the ABBA right there? So my students really like ABBA rather than this notation. Okay, so it's going to be the derivative of the first times the second plus the derivative of the second times the first. And that is my ABBA rule. Okay, so now when do we use it? Do we use it or do we not use ABBA? So here we go. I'm looking at it. I have an x here and I have an x here. And what do I have in between? Nothing, sir. There's no plus, minus, times, or divide. So if there's nothing there involved, there's going to be a multiplication. So right here, this is the product rule. So the answer is yes, we do the ABBA. On the second one, here's my x and here's my other x up here. There's a plus between them. So those terms are separate. So we do not apply the ABBA rule. On the third scenario, I have an x here and I have a function here in terms of, it's a trig function of x, right? And there's no plus minus, so there's a multiplication here. So we do apply the ABBA rule. The next example, okay, here's an x, and here's an x. But in between the x's, I have a plus and I have a minus. So we do not apply the ABBA rule. On the last example, you're going to look at the last example. And on this example, I can rewrite it as square root of x times 1 over x. So here's a function of x and here's another function of x. So yes, I can actually hide the product rule in a quotient. Yeah, and a lot of you know that what do you call it? Products and quotients are one and the same if you rewrite it. Okay. So let's go back to the original scenario: x to the third times x to the fifth. So what we're gonna do is we're gonna do the simplify, then derivative, right? So all right, if I simplify this, x to the third times x to the fifth is gonna give me x to the eighth. Then I'm going to take the derivative, so we're going to do a derivative, that's going to give me 8x to the 7, and this is my answer. Alright, so now we're going to do ABBA. Here we go. Alright, this guy is, we're going to do the product rule. This guy is A, and this one is going to be my B. So I'm going to write down A prime B plus B prime A. So the derivative of the A bubble is going to be 3x squared times x to the fifth. Now the derivative of my B bubble is going to be 5x to the fourth times x cubed. Now I'm going to do simplification. Remember, now we're doing the derivative. We're doing the derivative first, and now we're going to simplify. So that's going to give me 3x to the 7 plus 5x to the 7. That's going to give me 8x to the 7. Wait a minute, that guy and that guy are now the same. So that is correct. So now, do you understand how ABBA works? ABBA is only when you're multiplying the x's, not when adding or subtracting. Okay? So let's try some more examples. Here we go. This is going to be my A bubble, and this is going to be my B bubble. So I write down my product rule, A prime B plus B prime A. So the derivative of my A bubble is going to be 1 times my B bubble cosine of x plus the derivative of cosine of x, which is negative sine of x, times my A bubble, x. So my answer, so my f prime of x is going to equal to cosine of x minus x sine of x. Now if you notice, I put this x, I put it in the front, just so that students will we'll multiply this one with this one. So we're going to distinguish them. Alright? Separate them. Let's try another one. Okay? Let's try this one out. Now, in this one, I'm trying to trick you. I'm trying to trick you because I'm giving you a product rule inside it, ones that are not product rule. So right here, I have a product rule, and here, this guy is not a product rule, and this guy is not a product rule. So let's go ahead and do the product rule. Here's my A bubble, and here's my B bubble. Okay? So the derivative of A is 1 times cosine of x. The derivative of cosine is going to be minus sine of x times x plus the derivative of 3x is 3. The derivative of ln of x is 1 over x. And this is going to equal to y prime. So my derivative can be written as 3 minus 1 over x plus cosine of x minus x sine of x. And this function will help me find the slope of this function. Okay? So let's try one more. Now in this last scenario, I'm noticing that I'm not giving you what? I'm not giving you the product. I'm actually giving you a quotient. So what we're going to do is we're going to rewrite this as secant x times 1 over x. All right, so this will be my A bubble and this will be my B bubble. So let me write down A prime B plus B prime A. So the derivative of secant is going to be secant x tangent of x times my B bubble, which is 1 over x plus the derivative of B. Now if you saw my another previous video of mine, I told you to memorize the derivative of 1 over x as negative 1 over x squared times secant of x, and this is my answer. Now if you were to do a different rule, which we'll do it a differently, so I'm just gonna go ahead and if you want to have the same denominator, then we're gonna multiply this guy by x. I multiply by x here and by x here. So now on top I'm going to have x secant x tangent x over x squared minus secant x over x squared, and now they have the same denominator, so I'm going to end up with x secant x tangent x minus secant x all over x squared, and this is also an answer. Okay, so that's going to conclude my video on the product rule.